What is going on, everybody?
Good
Hi, hello.
afternoon.
Happy Thursday. And we're getting so close to the holidays. So, for those of you guys we won't see next week, happy Thanksgiving.
Yeah, happy Thanksgiving.
So, today should be an interesting one. We are talking malicious LNK files. This has been a pretty cool concept. It's nothing new. We've seen this abused all the way back to 2017 at this point. So there's a long history of it. It has become more prevalent as of late, with a lot more detections cracking down on like macro abuse and some of the other ways that threat actors tend to be trying to hide their ways of dropping or execution downloads, stuff like that. So this kind of made a resurgence, I guess you could say. So we figured
Yeah.
we'd tell you guys a little bit about it, how we do it as a Scythe test campaign, and kind of just show you something cool. Um, just as examples, some of the stuff here recently that you would have seen, groups like Charming Kitten, so Iran or Enumerate on Russia, are all currently using these LNK files. A lot of the times they're doing it to pull in things like drop a malicious HTA file and have that ran. They're employing them through RAR archives, where they're using those in different campaigns as well. It's probably like two of the most common ways we've seen here recently. And it doesn't look like it's going to slow down anytime soon, because it's not just nation state capabilities as a silo. Like, we're seeing this from anyone from normal named APTs to crimeware groups to pretty much anyone and everyone that's looking for a foothold nowadays. They're starting to take advantage of this one. But with that in mind, let's talk a little bit about LNK files themselves, the structure real quick, and then I'll pass it over to Jared. Obviously, it's not Tyler. We have Jared this week, because Tyler is on much needed break.
Yep.
And he will talk to you guys a bit about the test we have created, what all it entails, and then show you guys some cool potential paths for detection. Let me pull my screen up here. So, LNK files, realistically, what are they? TLDR, it's a shortcut. It's a link to something else on the platform, or for it to do a thing. It has really 5 main structures to it. The first piece being kind of what you can see here in open out on my screen, which is just that link header itself. It's going to contain any of the potential flags, telling the system what's turned on, what's turned off, creation times like timestamps, indexes, that kind of stuff, if there's a hotkey set. It's not too crazy from the beginning, so that part is simple. It just basically tells the platform if it needs to read lower and where to find all the data. The link target, this little ID list here, this is just basically showing you the path to whatever you're asking it to do. So this structure, it'll specify the target of this link itself, and its present is noted up here in this file flags path, where it says like has target ID list, has link info. All of that specifies that this is down here. In this instance, for this one, you can see it's basically saying, hey, we're looking in this path from my computer in a directory called Windows, System32, PowerShell, looking for PowerShell exe. So what's the target doing is what this is feeding us. From there, the next portions of the actual LNK itself, this link info and data, what this is providing us with is basically link info is an optional structure of itself that's going to specify any information necessary to resolve the target in that link. So this could vary based on if you're doing something local, like in this instance, calling PowerShell, or if you're telling it to do something, say, from a share or from the wider world, however you wanted to look at it. And then the next piece below it, string data, this one is basically how you would provide it, and how you're seeing a lot of threat actors kind of abusing this. They're using this space and then the resulting white spaces to specify, say, command line arguments or certain things for it to do. So down here, we can see, like in this example, it's got the relative path, which we kind of mentioned previously, in the target ID. And then any command line arguments we want to feed it. So let me scroll over here a bit. We can see this one. It's got a command line argument telling it we want to open PowerShell as a hidden encoded command and parse this string in base 64. So that's kind of the basic structure. This extra field down here is exactly what it says. It's extra. If there's any other attributes or information that needs to be known, it all just kind of falls down in there. But in a nutshell, that's really what a LNK file is, how its structure looks. Now, why was that relevant? Understanding how these are typically structured kind of lets you know how they're going to be taken advantage of, how they're going to be used, and how you could potentially look and detect them. So I've given you a quick little example of a basic. This is a forensics dump from one that's actually generated by our test, but it's a quick little basic look at how these are typically structured and set up. And with that in mind, let's show them what we actually have set up as a test here, Jared.
Yeah, sure. Let me steal
And
the
what I
screen
just
share
saw
here.
through.
Right. All right. So what we wanted to do with this test plan is we wanted to show a few different ways that these malicious LNK files can be set up and utilized for things like execution, exfiltration. They can also, like, for example, one of these is going to emulate HTTPS beaconing to C2. So just for a quick overview, we're going to start and just create a directory that will stage all these files. And we are going to pull in a benign PDF and then also a payload. This one is going to be a malicious HTA file. And then we'll also pull in some data that we're going to exfil. So what this test starts out with is using the LNK file for malware execution. And what we did for this, and I'll show in a moment once I finish this, is that we actually built out PowerShell scripts that can be used to fill out the fields of an LNK file and compile it for you and put it in whatever directory you'd like. Which kind of gives you a good way to test specific execution methods or specific things that these LNK files can do. So this one is basically run, and it creates a Windows update.exe.lnk in downloads. And when that is run, it will run the payload, which I will show momentarily. Next, it is a simple data exfiltration. So this one is very similar. It creates that LNK file with the payload. And this one basically pulls in a financial report, and it masquerades as a .pdf.lnk. And you open it, and it will open up that PDF. But in the background, it is actually exfiltrating sensitive files out to gray exfil. For this one, ugu.se. And then the last one is a simulated like C2 beacon being implanted by the LNK file. So again, it is built out, and this one is designed to masquerade as Office 365. And when you execute it, it will open up office.com in your default web browser. But in the background, it will simply simulate beaconing over HTTPS in the background. And then we remove it, and I will now share the code for you. Here we go.
So these are three interesting ways just to kind of give you a little bit of flexibility in your testing, but also to show you the different capabilities that you can take advantage of with these. All in all, it's a pretty interesting and sneaky kind of way of going about it.
Yeah, it definitely is. All right. So here are the PowerShell scripts that build them. And basically what they do is you just set variables for each piece. So for example, the path that it will go to, the shortcut it's creating with the path as an argument. And then here is where the meat is, this command field. So this command field here is what will actually be executed when the LNK file is clicked. This one specifically takes this command and encodes it in base 64 and then executes. You can also see down here, this is the target path. You can also see the arguments. So this one is hiding the window and using an encoded command. And what this is really helpful for is there is a limit, character limit in the command field. So it's helpful to base 64 it, to set arguments and things separately in whatever fields they can be broken out into. to allow you to execute longer lines of code. This exfil one also here, it has a pretty simple command. It's a 4 files command that takes things from this LNK staging and curls them up to ugu.se. And while it does so, it opens up this financial report. And then the last one here, this one basically will pull, this also simulates pulling in from C2. So there's a payload here in PowerShell IEX cradle to wget, and then run this beacon file here, and then create a registry persistence here that will download that PowerShell file again onto disk and allow it to run. And I can also show what the link file execution looks like to give a bit more context. Give me just 1 second. Anything you want to add, Trey, while I get my screen up?
I think all in all, the second one, especially for data exfiltration, is really interesting to me because of the path that it's taking. Like, this could be something used as like a secondary stage. So you went in, you did initial discovery, put a bunch of stuff in a directory. Now this LNK is coming in behind it to kind of mask what you're doing. You tell it to look at that staged area, take all the files within it, and send them somewhere else.
Yep.
Which, I mean, it's an interesting kind of sneaky way for me.
Yeah, that's a really good point. It is kind of like another bit of the toolbox. Like, it's probably not going to be anything past initial access, or like it won't be something that kicks off the full kill chain, but it is an interesting thing to have in the toolbox. So I went ahead and ran the script to create this Office 365 shortcut here. And when you open it, you will see that. And let's see if it actually, yep, here we go. So I went ahead and had it open this window here, and you can see.
Jared, can you zoom your windows a bit?
Yeah.
So they might be a little blurry for people.
Yeah. Here, let me see. I'm on RDP, so I think I have to use magnifier.
There we go.
Yeah. Sorry, it's incredibly laggy. But as you can see, it is posting to this http://bin.org. Which, if you don't know what it is, it's a very simple service that you can send requests to, and it simply echoes it and then drops whatever you're sending to it after the echo. So it's a great way to test like HTTPS, like beaconing, to be able to see, for example, like a process reaching out to HTTP bin instead of like a C2. But that's an example of the link execution. Is there anything else you had, Trey?
No, I think those are good examples. Before you dive into detections, I think it'd be interesting to show them the pie piece real quickly you were using for the build.
Yeah, here. So let me get this. So the output that Trey was showing at the beginning is from a Python library called LNK parse3. And I wanted to just share that real quick because it's a very easy and helpful triage tool. And I will drop this in the chat. So this is a super simple Python library. All you need to do is run the CLI against a link file, and it's a simple pip install, and it will output just like this. Like what Trey was showing earlier. This is super simple, super easy way to get all the metadata extracted from an LNK file. You can see down here, it's got the status implementation. So it doesn't pull quite everything yet, but it's currently in progress. And it's a really, really good tool for quick analysis of LNK files.
Okay. All right. Well, that's what the test is doing in a nutshell. There's a quick little way to kind of parse these after the fact. Let's show them some of the detections you have set up, Jared.
Yeah, for sure. So it's kind of interesting detecting these LNK files because it is a little more difficult to do anything state-based relating to the LNK itself, other than looking for specifically creation of that .lnk. Otherwise, you're going to need to correlate it into like processes or whatever spawns from it. So for example, we had 2 Sigma detections for this. One is just a keyword detection looking for .lnks. And then this one is also looking for like spawned off cmd.exe. And then we do suspicious processes after execution. So this one will require some correlation. And what this one picks up, you can see this is our encoded base64 command. And then all of this is all of these are the file events from these LNK files. So it's a little bit difficult to actually detect the specific link files themselves or the specific behaviors related to the specific file. You kind of have to give it a holistic look in the context of what else was running at the time. Is there anything you wanted to add, Trey?
Something of note here, if you're looking at these from a detection perspective, this is from them being ran via CLI. So this would look a little different if, say, like you'd fished a user, it dropped a RAR, unpacked it, and then they double clicked on it. You would see a different path of overall parent process and execution.
And yeah, Vic, that is a good point. It is difficult to actually find the like process chain for this, but yeah, there is evidence of the suspicious creation, like you said. That's a great point.
So yeah, all in all, I think that covers it pretty well. Is there anything else you wanted to kind of give them as a tidbit based on LNK files here, Jared?
Nothing specifically. I think we covered everything.
Well, awesome. Hey, look, we're actually on time for this one this week.
Yeah.
So that's what we have for you guys this time. I know we're wrapping up into the holidays. I believe we might have one more of these in December. But outside of that, we will start fresh again in the new year with a bunch of tons of new content, workshops, live streams for you guys. In the meantime, stay frosty, cyber nerds. We'll talk to you again soon.
Yeah. Bye.